finger vein detection using deep learning. Research in the need of the robust identity authentication measures spans across the diverse sectors, encompassing the data protection and the network establishment. In response to these escalating security demands, finger vein recognition technology has emerged as a viable solution. This technology operates through the two-step process, feature extraction and the subsequent matching of the finger vein pattern. Nevertheless, the inherent complexity of the finger pattern, marked by the irregular data quality, concealed segments, and considerable noise, poses a formidable obstacle to accurate feature extraction and the matching. To surmount this challenge, a novel approach is suggested, entailing the utilization of the deep learning by a finger vein recognition system. This innovative system promises the superior verification capability compared to the prevailing methodology, thereby bolstering the security measures across the various domains. Presenting a novel concept as a finger vein recognition mechanism harnessing the power of deep learning, surpassing the prevailing methods in the verification efficacy. The innovative system targets the elevated security demands, primarily countering the spoofing assaults while concurrently enhancing the accuracy and the swiftness of authentication procedures, particularly in the context of purchasing the electronic device. The proposal underscores the intricate nature of the biometric system in the terms of temporal and spatial complexity. Consequently, a finger vein recognition system emerged as a fitting remedy capitalizing on the potential to cater to the request of the robot authentication. With its amalgamation of the advanced deep learning technique, the system holds the promise of a multifaceted solution to contemporary security challenge in authentication realm. These are the basic requirements that are needed to build this project. The software requirements are Python IDE version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4GB, hard disk of minimum 250GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. This step involves importing the necessary libraries and packages like TensorFlow, PyTorch, OpenCV, and the other relevant tools for the image processing, deep learning, and the data manipulation. And the second step is exploring the dataset. The dataset containing the finger vein images is explored to gain the insight into the nature of the data, its distribution, and its format. This helps in understanding the dataset characteristics before pre-processing. And the next step is image processing. Image pre-processing techniques are applied to enhance the quality of input images. This includes resizing, normalization, noise reduction to prepare the image for the further analysis. And the next step is loading the pre-trained model. A pre-trained deep learning model such as YOLO V5 is loaded. These models are trained on the large dataset for the object detection task and be adopted for the finger vein detection. And the next step is data augmentation. To enhance the model generalization, data augmentation techniques like rotation, flipping, and the color adjustments are employed. This diverses the training dataset and aids in the model in recognizing the finger vein pattern under varying conditions. And the next step is processing the data based on YOLO V5 model. The chosen model and this of YOLO V5 pre-process the images for the finger vein detection and an object detection model that can detect the localized object within the images. And the next step is building the model. Here various models are built to involve the finger vein detection. And the first one is YOLO V5. It stands for You Only Look Once version 5. Is a cutting-edge object detection framework that rapidly identifies the objects within the images. Its architecture segments images into grids, predicting the bounding box and the class probability per grid cell and the single pass. In the context of the single vein detection, YOLO V5s use the real-time processing ensure the swift and accurate identification of the vein pattern, making it suitable for authentication scenario requiring with a quick response. And the next one is RCNN. It stands for Region-Based Convolutional Neural Network, is an object detection approach that proposes the region of interest, extract the features using SENN, and then fine-tune the object localization. This method excels in precise pattern recognition, making it suitable for the finger vein detection. However, its multi-stage process leads to the slower inference, making it more appropriate for the application, prioritizing the accuracy over the real-time processing. And the next step is user gives input as an image. Here we are building a Flask as a web interface where the user provides an input image to it. And the next step is the given input image is pre-processed with the trained model. Here the input image is pre-processing similar to the training data. This ensures the input image is suitable format of the model, and it is passed to the trained model for inference. This model identifies the region of interest that corresponds to the finger vein within the image. And the next step is the segmented each object and putting bounding box. The model output provides the information about the location and the boundary of the detected finger vein, and the bounding box are drawn around these region to visually represent the detected vein. And the next one is final outcome is display. The processed image with the bounding box highlighting the detected finger veins is displayed to the user. This outcome demonstrates the model ability to accurately locate the finger vein in the input image. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of annotations and images which containing of the different images within it. And the sample folder containing of the images that will be used to test the performance of the model. And the static folder containing of the folders like CSS, fonts, images, JavaScript, CSS files within it. On the template folder containing of the HTML documents, it typically include of home, index, sign-in, sign-up pages within it. And the YOLO is folder containing of the YOLO algorithm training images valid within it. And the app is an PY file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNP file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on enter button. After this we need to write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and then click on the enter button. Here and this way we can redirect it to this page containing of some information and title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some input details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password that need to be filled, and then click on the submit button. Here it will redirect it to this page containing of choose file and upload buttons. Click on the choose file button. Here it will redirect it to this folder containing of various images within it, and we need to select one image and then click on the open button and then click on the upload button. Here it gives a result as of with a bounding box for index finger, middle finger, ring finger and pinky finger. In this way we can recognize it with the help of YOLO V5 and RCNN modem. And by clicking on the choose file button we can upload another image of another image and then click on open button and then click on upload button. Here it predicted with as of like this. In this way we can identify the way by using the YOLO V5 and RCML. And in conclusion, the proposed fingerprint recognition system using the deep learning can provide the high verification compared with the other existing strategies. The importance of feature extraction in the fingerprint recognition and suggests that the deep learning approach can improve the accuracy of the feature extraction and matching. To emphasize the need for the public data set, the vast amount of information to improve the performance of the fingerprint recognition system. Overall, we conclude that the proposed system can be more appropriate solution for authentication and can address the security concern related to the spoofing attacks.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.